Okay, here we are with 2013A. There were 3 problems for this one. Depending on which period is watching, we did get to different points, so obviously you're more than welcome to stop the video as soon as we've reached the point at which we had stopped as a class. But I am going to walk through all 3 of them for my individuals who were absent, or for the periods who didn't get to touch on any of the 3, or for anyone who would just be curious to kind of hear one of them re-explained. So here we go. Number one reads, on a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this function. Okay, so I'm already going to be breaking this down. First of all, I know this is a calculator problem, so I'm already going to be looking for, as I'm working through this, places where I can allow my calculator to do the work for me, therefore saving myself some time. Again, 15 minutes per problem. This one's a 4-part problem, so we're looking at a little under, but around 4 minutes per problem. Slightly under 4 minutes, but about in that general area here. Okay, so first thing from this sentence that I'm already recognizing, on a certain day, the rate, so this is a derivative. I know I have some units here, tons and hours. If I was looking at, acceleration, a second derivative, I'd be thinking tons per hour squared. If I'm looking at the integral of this derivative, if I'm looking at, position or distance or something like that, I'm thinking tons. Well, it wouldn't be distance for tons, but you're getting what I'm saying, right? The integral of my derivative, the antiderivative, right? So here are my units. This is the rate or the derivative at which gravel is arriving at a gravel processing plant. So already my question is, am I also going to be given one where it's leaving? Right? Because then I could potentially have a subtraction problem there, right? How much arrives minus how much leaves is what's at my plant. We've looked at a couple of those now with, water flowing into a container and coming out of a container, that type of thing, right? So my brain's already making that connection. I'm wondering if that's something I'm going to be seeing. Maybe not, but it's something my brain thinks about. Okay, and then of course I am going to recognize that I've got a function here. And I usually start with plugging that in already into my graphing calculator. Right? 90 plus 45 cosine of my t squared, which I'm going to call x squared, divided by 18. Okay? Because if I end up not needing that one, I can always go up and unhighlight it. That's F4 on the 89s. On the 84s, that would simply mean going over the equal sign and unhighlighting the equal sign by clicking enter, right? If you didn't want to consider it anymore, if you didn't want your calculator to use it. Okay? But for now, I'm going to leave it. And then t is measured in hours. We have an interval here, 0 to 8. Okay? That's associated with my g of t here. At the beginning of the workday, at t equals 0, the plant has 500 tons of unprocessed gravel, right? So I'm already thinking here, I'm going to call it x, even though I know it's not technically a position, but I'm going to think of it as a given position, right? At t equals 0, I have 500 tons. During the hours of operation, 0 to 8, the plant processes gravel at a constant rate. So here's another derivative we've got here of 100 tons per hour. So this is my processing equation here, right? This is what's getting churned at my plant. Okay, A, find g prime of 5. Using correct units, interpret your answer in the context of the problem. Right? Okay, so to find g prime of 5, this particular part here was worth 2 points. 1 was for g prime of 5. Now you could solve it by hand. Actually taking the derivative 90 would be 0. 45 is a coefficient, so it's just going to hang out. The derivative of cosine t squared over 18 would be chain rule. So you'd have the derivative of cosine, which would be negative sine, leave the guts alone, and then the derivative of your guts, which would end up being t over 9. Right? And see, again, you could calculate that by hand, but personally, I would recommend, because it is a graphing calculator problem, let your graphing calculator do that work for you. I'm going to go ahead and set my interval of 0 to 8 here. And let's do let's do negative 10 to 10 for now. Right? And then you go, well, looks like that's not big enough. Let's go ahead and go bigger, right? And honestly, if you look here at the 90, you're already probably thinking like, okay, this is going to be rather large. Plus, my first, my initial amount here is 500, right? So I'm already thinking like these are going to be fairly large numbers here, right? And so you might go even bigger. And you're like, oh, okay, still not large enough. Right? And again, this is something you're going to have to walk through potentially. You're like, oh, I saw a little part of it. Okay, I'm getting closer, and so then you come back and you do, I don't know, 50. Right? Like, there we go. Now, for the record, because I wanted to demonstrate the like guess and check method, but for the record, if you wanted to have a little bit more of a surefire route, you could take 0 here, your x equals 0. You could plug 0 in here, right? You would have cosine of 0, which is 1, and 90 plus 45 is 135. So you would already know, like my top y here would definitely need to be at least 135, if not a little higher potentially, right? If you wanted to guess. Or, sorry, if you didn't want to guess. Okay, but so we've got our graph here, and then your calculator can do it. Second calc on 84s, F5 on 89s. Derivative is number 6, dy dx. And then you can tell your calculator, I want my derivative, I want my g prime at 5. And you type in 5, and then your calculator say, okay, your derivative is negative 24.5875. And so you'd write that. Okay, my g prime of 5 is negative 24.5875, and that was a point for the derivative at 5. Your second point was for the interpretation with units. Okay, and so then you're sitting there and okay, so this is g prime. G is the derivative of g. G is a derivative itself, right? G was a rate, or is a rate. G is the rate that the gravel is arriving at the plant. So you're going, okay, so G prime would be the rate of the rate. G prime is the acceleration or the rate of change of the rate, or however you want to phrase it, right? At which what are we processing here? Gravel, at which the gravel is arriving at my gravel processing plant, right? And so again, you'd have to phrase it however you wanted, using correct units though. So now that you've identified that this is acceleration, right? This is the rate of my rate. Our units now are going to be tons per hour squared. Since g was tons per hour, its derivative would be tons per hour squared, right? This here was my phrase or my explanation. G prime of t is the rate of change of the rate represented by g of t. Therefore, g prime of 5 means that the rate at which the gravel is arriving at the plant is decreasing at a rate of 24.5875 tons per hour squared at time t equals 5 hours. Now notice, because I said decreasing, I didn't write a negative out front. If you wrote is changing at a rate of, then you'd say negative 24.5875. But key here is you would need those units, tons per hour squared, right, at time t equals 5 hours. Okay? And then notice I used rate twice because this is a second derivative. This means the rate at which the gravel is arriving at the plant. That's describing g of t, right? G of t was the rate at which the gravel arrives at the plant. And that rate is decreasing at a rate of. Right, that rate is changing at a rate of, right? So a second rate here, a second derivative, because it's the derivative of my derivative, right? So you do want to make sure you're careful with how many times you used that rate phraseology. Okay. Okay. B reads, find the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday. Okay, so total, I'm already thinking integral here. Okay, total amount of unprocessed gravel that arrives, so I'm thinking the integral of my G, because G talks about the arriving at the plant. Right, during the hours of operation, I know my hours of operation are 0 to 8. Okay, so B was worth 2 points. 1 was for that integral, the integral from 0 to 8 of my G of t. So this was 1 point. And then 1 was for the answer, which is when you take that and you plug it in. You could do this a couple of different ways. We've reviewed already several times how to plug integrals in our home screen. Let's go ahead and look one more time at how to do it in your graph screen if you choose to do that way. Now obviously if you're going to do it in your graph screen, you need to make sure you're looking at the integrand in here. Right, so my y is my g of t here. And then you can do second calc on 84s, F5 on 89s. Integral is down here on number 7. And then it'll say, okay, from where to where? What's the lower limit? Our lower limit is 0. Hit enter, and they're saying, what's the upper limit? And you say, I want to go over to 8. So you type in 8, and it's going to fill it in for you here and calculate it. And as it's doing that, I'll go ahead and say already that the answer is going to be 825.551. Here, 825.551. Right, so that's my total amount of gravel, and so that would be a point for your answer. Okay. C. C reads, is the amount of unprocessed gravel at the plant increasing or decreasing at time t equals 5? Show the work that leads to your answer. Okay, so as you're reading this, you should be dissecting it, breaking it down. Okay, increasing or decreasing. I know that these two are talking about derivatives. This would be my derivatives positive to be increasing, my derivatives negative to be decreasing. We're looking at time t equals 5. And then so to answer that, we need to figure out, okay, I need my derivative to be positive or negative. So what's my derivative? Right, so I can look, is it positive or negative? And again, remember, this is at the plant. So this isn't just G of t, right? This matches to those water problems we've done already, or the water going into a container and coming out of a container. This isn't just G of t, because G of t is just what's arriving at the plant, right? You also have what's being processed, right? What's leaving the plant, and we were given that rate as well. That rate was 100 tons per hour. And so the rate that's happening at the plant is the interaction between those two. The amount coming in minus the amount leaving. My G of t minus my 100. Right? Comes in, goes out. If you subtract that, that's what's at the plant. Okay, this one here was worth 2 points. And the first point is for comparing G of 5 to 100. Right? Comparing how much is arriving to how much is leaving. And then the second one is for your conclusion. Right? And so this is how I wrote it myself when I did it. Right? I said G of 5 equals 98.1408, and I got that by simply plugging 5 in, right? If I plug in 5 into my G of t here, I get the rate that the gravel's arriving, right? And I find that the rate that the gravel's arriving is 98.1408. And then I say that 100 is the gravel being processed, the amount leaving, right? It's the amount leaving here. And so your first point here, I had to put it over here, but it is from the comparison, right, between the two, which is to subtract them, to identify that the amount arriving and the amount leaving, okay, the amount arriving is less than the amount leaving, right? And so therefore, okay, their subtracted amount is the rate of change of unprocessed gravel at t equals 5 hours, right? And then because, notice here, right, because this subtraction is negative, because the amount arriving is less than the amount leaving, that means the derivative, the rate at the plant, is going to be a negative number. And because my derivative's negative, that means that the amount of unprocessed gravel at the plant is decreasing. Right? And so that's what I wrote here. Okay? The amount of unprocessed gravel is decreasing because its rate, 98.1408 minus 100, is negative. Right? My conclusion here. Okay? In terms of how they wrote it on their little rubric, I'll go ahead and show that. They wrote it like this: G of 5 equals 98.140764, which is less than 100. At time t equals 5, the rate at which the unprocessed gravel is arriving is less than the rate at which it is being processed. Therefore, the amount of unprocessed gravel at the plant is decreasing at time t equals 5. And then here you can see those 2 points, one for comparing G of 5 to 100, one for your conclusion. Okay. Part D. Part D says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Justify your answer. Okay, so maximums. I am already thinking, okay, maximums. I know there are 3 locations of maximums. You could have the left endpoint or the right endpoint. So I will call it endpoints. That's 2 of my locations. Or any relative maximum. Right, this would be the other place for a maximum. And then we're talking maximum of unprocessed gravel at the plant. So I know I'm looking at that subtraction, the G minus the 100. During the hours of operation, which I know are 0 to 8. Okay. And then justify your answer. This one here was worth 3 points. The first point says considers that A prime of t equals 0. Right, so why would we be considering that? Well, remember, a maximum could be at a relative maximum. Well, how do we find a relative maximum? We take a derivative and we set it equal to 0. Right? And so, when they call it A prime of t, by the way, they're identifying A prime of t as being G minus 100. For part D here, you wouldn't have to call it necessarily A prime of t, but if you said, so my rates, my derivative at the plant has to equal 0, this was worth a point, right? And the reason we aren't taking the derivative to set it equal to 0 in this problem is because we are already given our derivatives, right? These were rates. G was a rate. 100 is a rate. They already took the derivatives for us and set it equal to 0. Okay? Your second point is for your answer, and your third point is for your justification. Okay, so we're going to go ahead and talk through some steps here to figure out where your answer would potentially, or how you would come up with your answer, right? And so you would take this, you'd plug it into your calculator, you'd calc your zeros. Okay, if you need a review of how to calc a 0, please ask when we come back from break. But calculating a 0, you get t equals 4.92348. And so to test, is that where the maximum is, or is it in fact at one of my endpoints, right? Because it could potentially be at either 0 or 8 at one of my endpoints here. Right? We need to actually figure out what the amounts are. Well, we know the amount at t equals 0. Right? At t equals 0, we were told we had 500 tons. Right? So 500 tons at t equals 0. Okay, so the question is, well, how can I figure out how much I have at 4.92348 and how much I have at 8? Well, you want a desired position, a desired amount. That's this x sub a plus the integral from a to b. Right? My given position, which in this case I was given 500. My given time, which I had 500 at t equals 0. And then the desired time. Well, I have 2 desired times. So let's go ahead and set up a second interval here. Okay, one of my desired times. Oh, sorry guys. I'll have to pick this up later.